We are MAT183 students. Our topic today is a solution of rate of change by using differentiation. First of all, differentiation is an action or process of distinguishing between two or more things. In order to find the rate of change, students are required to use differentiation instead of integration. The derivative fa is instantaneous rate of change of y equals to fx with respect to x when x equals to a. When the instantaneous rate of change is larger than x1, the y value on the curve are changing rapidly and the tangent has a larger slope.
Of topic rate of change. So the question will be a rectangular water tank is being filled at the constant rate of 20 liters per second. The base of the tank has dimensions W equal to 1 meter, which is the width is equal to 1 meter, and L equal to 2 meters, which is the length equal to 2 meters. What is the rate of change of the height of water in the tank? So in this question, we don't know the height. So the objectives of this question is to find the rate of change of the height of water in the tank. So solution for this question will be like this. First of all, the volume of the water tank, we can determine the equation V equal to width times by length times by height. So we know the rate of change of the volume is dV over dt equal to 20 liter per second, as you can see this at the question above. So we need to find the rate of change of the height of water, which is dH over dt. So we can conclude that dV over dt equal to width times by length times by dH over dt. Therefore, we can find the formula for dH dt, which is it will be dH over dt equal to dV over dt divided by width times by length. So the questions above, we need us to convert the liters into centimeter cubic or cubic cm and meters into centimeter. So in order to do that, 1 liter equal to 1000 centimeter cube and 1 meter equal to 100 centimeter. So lastly, we can evaluate the rate of change of the height of water, which is we can substitute the value inside this equation, which is dH over dt equal to dV over dt divided by width times by length, and we substitute the value inside this equation and we will get the answer, which is 1 centimeter per second. So that's all from me. Thank you.
So Sana's bubble blowing machine blows spherical bubbles whose surface area increase at the rate of 25 cm square per second. What is the rate of increase of the radius of a bubble when its radius is 2 cm? So from the question, tells us the surface area here. Surface area increase at the rate of 25 cm square per second over second. Next is, it tells us that the shape of the bubbles is a spherical. So we will write it. So the surface area increase at the rate of 25 cm square per second means that the differentiate of area over differentiate of time is 25. Then we know that to find an area of a spherical is using formula. The area of bubbles is 4 pi r power of 2. So we differentiate the area, then we will get 4 times 2 is 8 pi r. Now from the question again, equation 1, the radius of a bubble when it is 3 cm. So we just change the r to 3, then we will get 8 times 3 is 24 pi, as simple as that. Now using the formula dA over dt equals to dA over dr times dr over dt. We can simply change the value from where we get earlier. So we know that dA over dt is 25 from here. Then we also have dA over dr, which is here. Radius 3 is 24 pi, then times what the question need, the rate of increase of radius. Okay, then just we divide both with 24 pi, then we will get dr over dt is equals to 25 over 24 pi. Okay, therefore the rate of change of radius is, just go to calculator and we get 0.33 cm per second. So that is how to find to solve the problem. Thank you.
Hello, my name is Russell Roy. In conclusion, from this video, students will be able to determine the equation that is needed to be used to solve rate of change depends on what the questions ask by using differentiation and differentiate power function. Other than that, students also will be more aware for keywords such as radius, volume, area, and many others. In a nutshell, students will understand and work with derivatives as rates of change in mathematical models.